in 6.3, and this is sort of the part 2 of 6.3. We are learning the classic polar curves and the names of them. So here are the names. First, we have circles. Then we have limacons. That's how you say it. Limacon. That C is a soft C. It's like a S. So limacons. I wrote it here like how it sounds, limacon. And then we have roses that look like they have petals. And then we have limnoscate. It's actually limnoscate. Limnoscate. I don't know why, but that's how you pronounce it. I looked all these up, so I said it right. And then the spiral of Archimedes. So now I'm going to slowly go through how you know which one is which. Okay? So the first thing we know and we're going to learn is the circles. And the circles are always in the form r equals a sum a and cosine theta, or r equals a sine theta. So anytime you see an equation that's giving you just a cosine with a coefficient in front of it or a sine, you know you're going to get a circle. Now, there's something about a that tells you what kind of circle it is. First of all, if it's a cosine, it's going to be symmetric to the polar axis. Okay, so here's the polar axis. And if a is greater than 0, it's going to be to the right. Okay? And if a is less than 0, it's going to be to the left of the polar axis. So study that for a minute. And then on the sine, if a is greater than 0, sine is symmetric to theta equals pi over 2. So I'm drawing those. It will be, if it's a is greater than 0, it's going to be it's going to be on the top, so it's up here. And if it's less than 0, it's going to be on the bottom. So take a minute to try to memorize r equals a cosine theta or r equals a sine theta are circles. Okay? Next set, the limacons. Okay, they're in the form y equals a plus or minus b cosine theta. So they just have a term with a plus or minus in front of it. So it's like, here's your circle, okay, and then it has a term in front. Or a plus or minus b sine theta. Okay, so symmetry will match the same thing as sine and cosine did. But let's look at, notice I called the first term a and the second coefficient in front of the second term b. So here's how you can learn, because there's different kinds of limacons. There's limacons with an inner loop. There's a cardioid, and there's a dimpled limacon, and there's a convex limacon. And so they all have to do with a over b. When a over b is less than 0, you have the inner loop. Okay, you have this guy. So there's one with an inner loop. And this has to be a cosine, doesn't it? Because it's symmetric to the polar axis. You have, if a over b equals 1, you have what's called a cardioid. And it looks like a heart. So it looks like this. And this one must be a sine example because it's symmetric to theta equals pi over 2. You have a dimpled limacon when a over b is between 1 and 2. So it's still kind of a heart, but it's a mini heart. It's called a dimpled one, and we really have to know that. And then when a over b is greater than 2, it's called convex. So yeah, you're going to have to memorize this. It's not that hard. Just walk away, study this, walk away, and try to, you don't need to graph it, you just need to know the symptoms of it. You'll see the examples. The next thing we have are roses. Roses are when you have angles, bigger angles, like 3 theta, 4 theta, 5 theta. N has to be greater than 2. All right? So, now, the N determines the petals. When N is odd, you have N petals. So, if it's odd, you have that many petals. So, if we have R equals 3 sine 3 theta, 2 theta, I'm sorry, I need to make it odd. 3 theta, that's a rose with 3 petals. If n is even, you have 2 times as many as n petals. So if I said r equals 3 sine 6 theta, n equals 6, so the petals is 2n. So we have 12 petal rows. Okay, so here's your examples. When it has 3 petals, a cosine 3 theta, we have symmetric to the polar axis, we have 3 petals. When it's 2 theta, we have 4 petals because that's even, so we have to double it. When it's 5 petals, it's 5 petals. When it's 4 petals, it's 8 petals. All right, so that's roses. Then we have limnoscits, okay? Now this is a stranger equation because it has the r squared in it. And this is usually an a squared cosine 2 theta. So if it's a cosine, of course, it's going to be symmetric to the polar axis. And if it's a sine, it's going to be symmetric to the pole. And the reason it's symmetric to the pole and not theta equals pi over 2 is because of this r squared. And lastly, most fun, is the spiral of Archimedes. All right, and that just means it's like this, okay? It spirals out. And that's when you just have r equals some number times a theta plus b could be 0. So if you have r equals 3 theta, that's going to be a spiral, or plus b. All right, so let's see what the first thing asks us to do in our notes. Okay, I'm going to erase all these. So we will go through them and make sure we get them right. So the first one is an r squared. So I know immediately that has to be a limnoscit. So I'm going to write that Limniscate. While you're learning it, learn how to spell it, okay? When I get 3 cosine 2 theta, this is a rose, right? Because it's just a cosine and then it has an angle bigger with, oops, not a roll. That would be a rose with 4 petals because it's 2n. Okay, this is a limicon. And so I'm going to write limicon. Remember, it's got that weird C. It kind of has a dangle C. And what kind? A over B is 4 over 3. And 4 over 3 is between 1 and 2. So this is dimpled. Dimpled limicon. Okay. We have a circle here. We don't have an angle bigger than theta. And it's just a cosine something. So this is a circle. This, see here, you have no trig function. This is a spiral of Archimedes. It's a name. All right, this one looks like a limnoscate. And we have A over B equal 1, so this means it's a cardioid. Next one, we have 2 sine 7 theta, so this looks like a rose. It has an odd number of angle, so that would be of 7 petals. This looks like a limnoscate. I messed up. This is not a limnoscate, it's a limicon. And the same thing, I keep saying limnoscate and there's no r squared there. So this is a limicon. And A over B is 1 over 2. So this would be have an inner loop. All right, and then r equals 3 sine theta would be a circle again. And lastly, this would be another limicon. And it's 2 over 1 because this is B up here, which is 2 greater than or equal to 2, so that would be convex. So there we go. You should be able to name those. It's good to practice that. The next questions we'll go on and use that to help us graph.